We'll be solving differential equations in this lesson. Now, a separable differential equation can be written in the form fx dx is equal to gy dy. So in that box there, that means that our x terms can be separated so they're on the same side of the equation as our dx, and our y terms are on the same side as our dy. Now, any separable differential equation can be solved. So let's have a look at our first example here. We're asked, which of the following differential equations are separable? So our first one, dy dx equals 5x over y. Now we'll just rewrite that. The first thing we're going to do is get rid of this y on the bottom of the fraction here. So we'll times by y on the right, do the same thing on the left. Now over there, those y's cancel out. So that leaves us on the left-hand side with y, dy dx, and that'll be equal to just that 5x there. Now let's get rid of the dx here. So we'll multiply by dx there and do the same thing on the right-hand side. So on the left, the dx's cancel out. Now that leaves us with y dy is equal to 5x dx. So we can see there our y is on the same side as our dy, our x terms on the same side as our dx, so therefore the equation is separable. Now let's have a look at part B. Dy dx plus sin x is equal to 3xy. Well, let's start off here by moving that dy dx down. Now we'll get that positive sin x there. We'll move that to the other side. So we'll be subtracting that, giving us 3xy minus sin x. Now having a look at that, there's no way we can separate those x's and y's on the right-hand side. Can't take any common factors or anything. So in this case, the equation is not separable. Great, let's have a look at example 2 now. We're asked to find the general solutions for the differential equations. So first of all, in part A, we've got dy dx is equal to x on y squared. So let's just write that out. Now the first thing we'll do is separate the variables. So the y squared on the bottom of the fraction, we'll get rid of that to begin with, multiplying by y squared there, and on the other side of the equation. So over here, the y squareds cancel out. Now on the left, that leaves us with y squared dy dx, and that's just equal to our x here. Now let's get rid of the dx over there, multiplying on the left and multiplying on the right. So the dx's will cancel out. Now that leaves us with our y squared dy, and that's equal to x dx. So we've got our y's with our dy, and we've got our x's with our dx. So we've completed this process here where we're separating the variables. Now we need to integrate both sides. So integral symbol there and another one there. Looking at the left-hand side first of all. Integrating y squared in terms of y, we get y cubed on 3. Then looking at the right-hand side, integrating x in terms of x, we get x squared on 2. Now important here, we need to remember to add the constant. So we'll put a plus c there. We've put it on the right-hand side, but any side will do. Now we'll get rid of the fraction. Now 3 there, we're going to multiply by 3 on the left, and we'll multiply by 3 on the right as well, making sure we put that whole right-hand side in brackets though. So on the left, they'll cancel out. Now that leaves us just with y cubed. Now we can expand out on the right-hand side, so x squared on 2, timesing it by 3, gives us 3x squared on 2. Now when we times that constant term c by 3, well that's just going to give us another constant. We don't know the value though, so we'll just write that down as plus k. Now looking at our equation there, it's in terms of y cubed. So to write it in terms of y, we need to take the cube root of both sides. So that gives us y is equal to the cube root of 3x squared on 2 plus k. Excellent, well there's our general solution. So let's try another example, part B. This time we've got dy dx is equal to x cubed cosec y. Now the first thing we'll do is rewrite the equation. So bring down the dy dx. But this right-hand side, we're going to rewrite that as x cubed on sine y. Now if you remember your trig work, cosec is the reciprocal of sine. So we can just change that to a sine and bring it to the bottom of a fraction. We're much more familiar with working with our basic sine, cos and tan functions. Now let's separate the variables. We'll get rid of the sine y on the bottom of the fraction first of all. So timesing by sine y on both sides of the equation. Over here they'll cancel out. Now on the left that leaves us with sine y dy dx, and that's equal to x cubed. Now we'll remove that dx. So times on both sides again. On the left they cancel out. So that leaves us sine y to y, and that'll be equal to x cubed dx. So let's check. We've got our function of y with our dy, our function of x with our dx. So separating the variables is done. Give that a tick. Now we need to integrate both sides. Integral symbol here and another one over there. Now integrating on the left-hand side first of all. The integral of sine y, well that's negative cos y. And then integrating our x cubed over here, that gives us x to the 4 on 4. Once again, don't forget, add that constant term c. Now we've got a negative cos here. If we times both sides of the equation by -1, that'll change that to a positive cos. This here will become negative x to the 4 on 4. Now our plus c, well that'll become a negative constant. Once again, we don't know the value of our constant, so we'll just write it as plus k once again. So to make y the subject of our equation here, we need to get rid of the cos. So we're going to take cos to the -1 of both sides. So that gives us y is equal to cos to the -1 of negative x to the 4 on 4 plus k. Fantastic. Well, let's have a look at a third example now. Here we're asked to solve dy dx is equal to 4x squared y, given that y is equal to e to the 36 when x is equal to 3. So let's write our equation out to begin with. Once again, we're going to separate the variables to start. So we've got our y here. We'll take that over to the other side of the equation first. So we'll divide by y there. Now on the left, we'll multiply by 1 on y. It's the same as dividing by y. So over here, the y's cancel out. Now on the left, we're left with 1 on y, dy dx. And on the right, that's equal to 4x squared. Now let's move the dx, so multiplying on both sides of the equation. On the left, as we've done before, they cancel out. So that leaves us with 1 on y dy is equal to 4x squared dx. So just checking our function of y is with our dy, our function of x is with our dx, so separating the variables done. Now we integrate both sides, so integral symbol there on the left and another one on the right. Now if we're going to be integrating first of all on the left-hand side, the integral of 1 on y, do you remember that one? Well, that gives us log of y. Now integrating the right-hand side, that's a bit easier. The integral of 4x squared is 4x cubed on 3, but don't forget, add our constant term c. So to solve the equation, we've got to get rid of that log. So we're going to take the exponential of both sides. The e and the ln will cancel each other out, leaving us with y is equal to e to the power of 4x cubed plus c. So that's our general solution. To solve the equation, though, we know these two values here. When x equals 3, y is equal to e to the power of 36. Now we're going to get that equation there and sub those values in. So for our y, we'll replace that with e to the 36. And then on the right-hand side, with that power there, 4x cubed on 3, well, we'll sub in x equals 3. Now when we sub in and simplify a bit, that gives us e to the power of 36 plus c. So e to the 36 equals e to the 36 plus c. Well, I think we can clearly see there that c must be equal to 0. So if we get our equation there, sub in c equals 0, the solution is y is equal to e to the power of 4x cubed on 3. Fantastic. Well, that's the end of our lesson there. Good luck now as you work your way through your questions.